In this video, I'm going to take on another ACT, SAT math problem. Here we have a geometry problem where it's given ABCD is a square of side 3. So there's our square, and each side is 3. And E and F are midpoints of the sides AB and BC respectively. So we know E is in the middle of there and F is in the middle of here. And the question is, what is the area of the quadrilateral EBFD? So how can we solve this? At first, it doesn't seem like it's an easy problem to solve if we're looking for this area. So what do? Well, there are a number of things we can do. We could try and divide that area into some triangles that we might be able to compute the area of. So let's do that. Let's take a line through here like this and separate that quadrilateral into two triangles. And then I know my area formula for a triangle is 1/2. Area of a triangle is 1/2 the base times the height. And this triangle here, I could label this the base, and I could label this length here the height, both of which I know because F is a midpoint, so B is 1/2. And H is the side of the square, that's 3. And I could plug that in to get the area of this half of the quadrilateral. I think it's pretty clear to see that we would double that to get the area of the entire quadrilateral because this triangle and this triangle are exactly the same. So that is one way, probably the way most people would solve that problem. What I'm going to show you now is an easier way to solve the exact same problem. And this time, what I'll notice is that the area of the shaded in region I can actually compute by taking the area of the entire square and subtracting these blue areas. So the area of the quadrilateral is the area of the square minus the area of the two triangles that I've shaded in, right? And then it's easy for me to visualize that these two blue triangles can be put together. Here's the one copied directly. And if I take this one and kind of rotate it and fit it right here, there it is. And that is exactly half of the area of the entire thing. So all I really need to get the area of the quadrilateral is half the area of the square. The square has side 3, so its area is 9, and I get 9/2. And I spent a lot of time writing down the notation, but if you saw that visual right off the bat, you could get the answer in a snap because the area of the square is 9 and half of that is 9/2. And you wouldn't even have to write down as many steps as I wrote down. So that's a quick way to solve this problem. Again, it requires visualization. It requires being flexible in your thinking and being able to visualize this triangle moving into and rotating into that spot so you can clearly see its half. So again, this is one of the simple things that we're going to show kids how to do in our SAT, ACT bootcamp. Almost every single SAT or ACT math problem has these kinds of little tricks that you can use to make it much, much easier than some sort of brute force method. Here is another classic SAT, ACT math problem. In a class of 78 students, 41 are taking French, 22 are taking German. Of the students taking French or German, 9 are taking both courses. How many students are not enrolled in either course? This can be a really difficult question, especially if you're going to try and set it up algebraically and start coming up with formulas. But once again, a visual technique tends to work really well on this problem. And that technique is to draw a Venn diagram. So here I will draw, imagine this is the space of all students, all 78 students. And inside of there's a group taking French, and there is a group taking German. And I made an overlap because some students are taking both. So let's go back through and see how we can fill in this picture. I know there are 78 students in all, so inside of this rectangle, I should have a total of 78 students. There are 41 taking French, so in this circle, in total, there should be 41, and for German, there should be 22. But the trick is, of the students taking French or German, which is the students in both of these circles, 9 are taking both, which I can fill in immediately. So I know that 9 students sit here in the middle, taking both French and German. Once I know that, I can fill in the rest. I know 22 students are taking German, 9 of whom are taking both. That means that there are 13 left who are taking German by themselves, or German alone. And similarly for French, there were 41 in total, 9 of whom are taking both, and that leaves 32 that are taking just French. Now I can add these up. 32 plus 9 is 41, plus 13 is 54. So I have 54 students taking French or German or both, and that leaves, and I know the whole thing adds up to 78. So 78 minus 54 is 24, and so I have 24 students out here taking neither French or German. So again, simple problem to solve using a visual picture.